Well, hi, good morning, and welcome to my shop. What I've done with this radio so far is replace a couple of capacitors and do the alignment a couple of times on it, and replace a apparently defective tube. And the result is, the radio is working much better. But still, in the last test at the end of the last video, I sort of became convinced that there's more to do with this radio than to let it go at this point. I think I can make it work a little better. That's really what I mean. Before I get into this though, if you're American, type IHME into your Google browser and study the website that shows up, or the pages that show up. IHME, if you're American. Well, if you're anybody, you can check it out, but if you're American, I think you'll find that very interesting. I won't say any more about that. Now, I think the approach I want to take is I'm going to consider the kind of problems that the radio is exhibiting. I'm not even sure how to characterize them right now. And then try to figure out, well, which capacitor in here might be responsible for that. So we still have this package, I'm calling it. There's another word for it I've forgotten, but this is sort of an integrated circuit here, very early integrated circuit. That's a real suspicious thing. And then we've got ceramic capacitors here and here, which are normally very reliable. You know, I just noticed that this one, oh, that's okay. Now this one's connected right to the incoming line here on the other side of the outlet. And there's one here. One, two, there's just three of them. Boy, I think I should just go ahead and change them all and see what I end up with. I'm going to try to find these on the schematic and consider what each one is doing and whether any of them could really be responsible for what's going on here. Yeah, let's take a look at the schematic. This will be difficult to pick off, I think. Okay, here's the schematic, and the capacitors I've changed already. This is one. This is a little curious. I put in a 0.01, which is what it says on the schematic, but I think the capacitor I took out was a 0.1. And it looked like it had been installed subsequent to the manufacture of the radio. It looked like somebody had put that in there. That's what it looked like. Somebody upped it to 0.1. Is that because somebody was smart and they knew that a 0.1 here would defeat some of the problems I'm getting? Good question. I don't know. Now the other one I've changed is this one. So that's a brand new capacitor there. And then all these ones with numbers on the terminals are part of this, and I can't remember the proper term for it, but I'll call it a package or an integrated circuit. You really can't call this an integrated circuit because it's not one piece of substrate and all these things have been created out of a substrate. I don't think it's done like that at all. I really don't know what's inside these packages, to be honest with you. So the potential for trouble here is really high. But I'm going to try to ignore this for now and kind of leave. This is the last thing I want to try to deal with. So that leaves some more ceramic capacitors here. There's one here, there's one here, and there's one here. Let's start with this one. Small capacitor against a small resistor in the cathode circuit of the converter tube. And we're driving the oscillator with this arrangement. Why this? So my guess is this 150 ohm resistor is to bias this tube, and this is just the bias bypass cathode resistor bypass capacitor. It's very small because you're bypassing RF here. In fact, here you'd be bypassing the oscillator signal. Well, everything I guess. That's to maximize the current flows effect, AC current flows effect on this primary. So none of it is wasted in this resistor. Put the capacitor there. This guy's not working well. I think the most you would get is a weaker local oscillator. I'm not sure. I mean, it's a very small capacitor, so you know how much smaller can it really get? Of course, I mean, these things could go open and they could be shorted. It's always possible, but I don't think that's the case in this radio at all. So this is a fairly large one, a 0.01, and it's doing something similar. It's providing a AC ground down to B minus here for this coil. And here's one here. This is a very small one again, and it's between the screen, I'm sorry, yeah, between the, whoa, what is it between? Careful now. Okay, so this is B minus, so one side of this, so this is going to B minus here. Yeah, and that's the suppressor at B minus, same as the cathode, everything at B minus. So this guy is draining out what? He's got a 680 ohm resistor to work against. This is B plus coming in. So we have B plus, 100 volts worth of B plus on here. So I think its job is to is kind of bypass this resistor to the B minus line. So that again, this coil feels all the weight of the signal coming out of here. It's not shared out with any other components, especially I guess, blah, blah, blah. So if this one were weak, well, that would be interesting. Now you'd be assuming this really is to filter out nearly all the RF to the B minus at this point. If it's not working well, you get some RF and make it through this resistor, and now it's got a run around on the B plus, work its way into other circuits. So I'm saying this one's pretty important, possibly, and this one could be part of the picture. And I'm not going to analyze these ones that are in the package just yet, because I think I'm pretty intent on going after. Is it 3? 1, 2, 3? Is that all of them? I think that's all of them. 0.01. Let's go for the big one first. So the 0.01 will be off of pin 7. Oh no, not necessarily. Well, we'll have to hunt for this one. It's related to this, but this is all wires all over the place here, so it's tricky to find them. There's only 3 capacitors, Jim. One of them's a 0.01. The other 2 are 0.02s. Hey, that should be easy, actually. Okay. That should be easy. Let's see how easy it is. So I'm trying to read the values on here. Unfortunately, they're all on the other side of the capacitors. 0.01 right there. Okay, and then the other 2 got to be 0.02s. 0.002s. This one and this one. Well, let's go for this guy then. We'll do the 0.01. I might have some ceramic. I got a ceramic one here. I can put another ceramic one in there, I think. 0.01. Okay. Okay, let's solder this guy up. Oh, wow, everything come off. Oh boy, everything just came off this terminal. Oh my gosh. Just a huge amount of solder on there. Okay. I'll start over here. So while I was trying to solder that the first time, one of the leads from this just popped off. That long wire just popped right off. Popped off because it was not actually wound around the terminal at all, and that tells me that's not factory. That's replacement. Or so it suggests anyway. So the suggestion is this piece has already been replaced once. Okay, that's one side of the capacitor here. Just take them down here. Shorten this up. Play hooky with this one. Lots of bare wires in here. There's one right here. It's almost shorting. Boy. Okay, hooky. Didn't leave myself enough wire. Once again, and I'm trying to keep the leads as short as possible, but lost the hook. There we go. Nope, hooked again. There. Okay, one capacitor. Is that enough to do the trick? Nothing shorted. Or enough to do a trick. Yeah, it could be that every one of these is causing little problems in the radio, and I'm hearing the culmination as you clear out each individual one. Maybe it's just a little piece of the annoyance disappearing. Hard to tell as you clear them out one at a time. Unless one guy is a real bad actor. Okay, I think we're ready to play the radio. There we go. First time today. Dim bulb work correctly. The actual time is 9:15, not 7:30. I was thinking a little more about how to clean these dots out from behind. I was imagining all kinds of stuff here. That dirt could be radioactive particles. Could have radioactive particles in it. Again, a volume, not too much to worry about, but you can't eat any of it. Any amount is bad for you if you eat it. Okay. Right on 640 where it should be. Dead on. 590. .680 is a tough one. Tough because there's a noise signal, about 5 kilohertz from it. 680 should be around here. It's right there. Some radios you can listen to this station and other ones sound like this. So only one possible adjustment I think that might help the situation here. I shouldn't really say that, there might be two. Sharpening up the IF might help. But the easy one to mess around with is this one, not with that. Not with that. With this. Tuning a bit. So there's 680 now resolved from the noise. The discussion there is Canadians talking about how to get along with the unreliable Americans. That's what that discussion is now. Something I never heard in Canada before. Never heard it. Now, shame on me for bringing it up. But, you know, hey, play the radio, the news comes out. I can't help but hear it. Okay, I think that might have made a little bit of a difference. Hey, wait a minute, don't just toss that into the bucket there. Let's test it. Let's test this and see what we get. My guess is this is going to test perfectly. Let's see. Ceramic capacitors, I hardly ever take these out of radios. I hardly ever test old ones. And I don't encounter them that much with the radios I work on. Most of the time it's tubular wax capacitors, not so much disc capacitors. Okie dokie. I do remember a great big communications receiver I worked on for hours and hours and hours, and finally found one of these shorted in it. And as soon as I replaced that, boom, everything back to work. So these things can't fail. Here we go, watching the eye. Right open. 250 volts, right open. Give it 350, who cares? Right open. So absolutely no leak through here whatsoever. That was as good as they show up. 0.01 we will find here somewhere. Just let's find it ahead of time. On the 0.5 scale, 0.01 is here. There we go. So you see, 0.01. Did you like the sound effects I added in there with that? 0.01, almost dead on, and this isn't even that precise or accurate. So there we are. So I replaced a perfectly good capacitor. I think that suggests the other two are probably perfectly good. My experience is 100% almost with these capacitors. Almost. That they are good all the time. That's a good guy. Okay, so what to do with this radio now? I think the last little bit of tuning I did with the RF adjustment, which is kind of focusing the front end around where the radio's tuned. So the radio's tuned to 680, and the front end, I'm going to say, was just a little high where the noise is. So what we're listening to, a weak 680 and a strong noise, and then just by moving the front end tuning a little bit, you sort of reduce the noise signal and increase the radio signal, and then there it comes out of nowhere. There it is. So considering where these radios are in the world, they're here in Ontario, and people are going to tune in the lower end of the band here in Ontario. They're not going to tune in the high end. There's nothing there during the day to listen to. There we are. I think it's done. I think we're finished here. Of course, if I bring in my antenna booster, right here, you can see a big difference in this radio's reception. Okay, I think it's back into the cabinet. The cabinet, yes. Let me just turn the power off here before I forget. The cabinet. Here it is. The cabinet. You see how somebody melted this hole. It could have been done with a drill, I don't know, but wow, kind of a messy job there. That's for the on-off switch. Looking for any cracks, especially along lines like this. No, this cabinet's good. Okay, I'll just clean her up, stick it on. And what about the front? Now I gotta make a decision on the front. I think my decision is going to be leave well enough alone in this case. Could get this front plate off. How dirty is it really? You know what, after I clean the front, this dirt appears to be on the front. Yeah, I think it is on the front. I think it's on the front. So clean it up. Clean her up. Clean it up. Let's see what we got. And here it is, the Executive, all back together. Unfortunately, the top of this radio is got some stains on it. I cannot get those off. If anything, they're more pronounced now that I've done cleaning and polishing on this radio. Too bad. But the chrome, of course, has come right up. Really nice. Get my fingerprints off of it. Okay, let's get it going. Okay, so the switch on the back is off. Clock is running. Now, can we set the clock? I didn't do anything with the clock. There's the date and that. And this is the actual time setting here. Very sticky, but it can be done. Great. What time is it? It's 9:58. You know, I should leave this running. 9:58. There's no going backwards here. Okay, we'll leave it like that. Turn on the radio. Okay. Radio's on. Volume's so. The big moment. The clock is really a great thing. Got a nice big dial on it. Boy, I Every time I turn these guys on, I think, uh-oh. What's all that? What's all that stuff? What's happened? Oh. Well, I guess I got something to work on tomorrow again. Oh, I can't believe it just went sour. Oh my gosh. Okay. Not okay. Son of a gun. Well, I guess I better leave the power on here. At least we'll find out if the clock works correctly. You know, I turn it off and wait for slightly after 10 to show up. Okay, very disappointed. Can't give up on this guy. Hey, it did go backwards. There we are, right there. Yeah, son of a gun. I wonder what happened. Something must have happened. Oh well. Tomorrow's another day.